Welcome you all to watch this video related to formation of stars. Here you will find how a star is formed, what phases of life stars will have to meet with, and finally what becomes the fate of the life of stars. First, know keywords. What is the Chandrasekhar limit? Chandrasekhar limit is defined as 1.4 multiplied by mass of the sun. This is the limiting or threshold value of mass of a star that will decide whether a star would survive or ultimately will collapse. And next keyword is a nebula. Nebula is the beginning of the star, isn't it? It's the cloud of dust and gas particles. And the nebula is mostly composed of hydrogen. So see how a star forms. The formation of a star began 4.5 million years ago with a nebula due to gravitational attraction amongst the nebula particles. Particles come closer and then new phase of the star, young phase called the protostar. In protostar phase, nuclear fusion is just about to start. Then next phase of the star after the protostar is main sequence phase or main sequence star. This is the most stable phase. And the sun and so many stars are believed to be in this phase for billions of years right now. In this phase, nuclear fusion takes place. Two hydrogen nuclei fuse together to give a helium nucleus and a neutron. Isn't it? Now, the two forces come into play within the star. One is the gravitational attraction amongst the particles. And next one is the force that is coming out of the energy released during nuclear fusion. See, in main sequence star phase, the two forces do balance each other. And so it is the most stable phase of the star. Now at this point, the fate of the star will depend upon the mass of the star. Two situations are there. When the mass of a star becomes more than the mass of the sun or less than the mass of the sun. That is the Chandrasekhar limit. First, come to see what happens when the mass of a star in main sequence star or after is less than the mass of the sun, that is the Chandrasekhar limit, 1.4 mass of the sun. Then this main sequence star goes to a new stage. This stage is called red giant star. In this phase, almost hydrogen nuclei have been used. Bigger nuclei begin to form, and the star after main sequence phase called red giant star looks red. Then the next phase, aging phase of the star, is the white dwarf. In this phase, there is no nuclear fusion, and that's why it is cool. And then white dwarf takes the new form, it's the black dwarf. This is all about the mass of a star in the main sequence phase and after is less than the Chandrasekhar limit, isn't it? Now come to the condition when the mass of the star becomes greater than the Chandrasekhar limit, much more the mass of the sun. Then main sequence star phase will go to a new phase called red supergiant star. Here, new nuclei just to form, and then red supergiant phase will go to a supernova phase. This is most interesting and significant phase. In this phase, hydrogen fusion no longer takes place. Already, hydrogen nuclei are running out. There is helium nuclei. Two helium nuclei fused together to give a beryllium nucleus. This is a heavy one. And now one beryllium nucleus will fuse with the one helium nucleus to give carbon nucleus. Here the bigger nuclei are formed. If this happens in supernova stage, the two forces don't balance each other. Here, the force coming out of the energy release during nuclear fusion will be much big, very big, and gravitational pull dominates. So there is a mismatch between the two forces, gravitational force and the force due to the release of energy during the nuclear fusion. And that's why there may be supernova explosion. And in supernova explosion, hot fragments are scattered in the universe. And all the naturally occurring elements present in the universe are the outcome of supernova explosion. We find the gold, it's the result of supernova explosion. Now, at the supernova stage of a star, again, the fate of the star, if the mass continues growing, maybe a neutron star or a black hole. Next phase of the star after the supernova is the neutron star. It's so called because in this phase neutrons are present. And if the mass of the star is much bigger, then you get black hole. It's so called. It's a black region where the gravitational force is so intense, so massive, that this region cannot allow even the light to pass through. That's why it's black. So this way, a star collapses. So whether a star is to survive or the collapse, that will depend upon the mass of the star as the star goes to different phases of the life. So, we began the creation of a star 4.5 billion years ago with a nebula phase and get black hole. This is how a star is formed, goes through different stages of its life, and finally dies out. That's all for the day. Thank you.